is a Devops CI/CD pipeline, and it includes Docker, GitLab, Jenkins, Snyk integration demo. It's done by students Sarah Photowat, Patrick McElvaney, Nicholas Monson. This is the part 3 of final project with GitLab installation as a prerequisite. Here is what we are going to cover in this demo. Here is a continuation page of what we covered in this demo. Here is the project statement for step 3. First, we need to install Docker and install Docker Compose. First, you install utilities and tools that are required by Docker, such as apt transport, HTTPS, CA certificates, curl, etc. First, you install utilities and tools that are required by Docker, such as apt transport, HTTPS, CA certificates, curl, etc. Here is the screen showing the installation of required utilities for Docker installation. GPG keys are added for Docker here. GPG is the tool used in secure app to sign files and check their signature. This allows for the secure transmission of information between parties and can be used to verify that the origin of a message is genuine. Here is the screen result for adding GPG. There are different methods for installing Docker. Most users set up Docker's repositories and install from them, which is easier for installation and upgrade. Here is the command for setting up Docker repository. Here is the result of running Docker repository setup command. Here is the command for getting latest update for Ubuntu, followed by the command for installing Docker. This screen shows that Docker is installed. With this command, Docker Compose gets downloaded. The reason we use Compose is because it's a tool for defining, configuring, and running multi-container Docker that will be used in this project. Here is the result of Docker Compose download. We need to give executable rights to Docker Compose. We also add the current user to the Docker group to be able to start, stop, login, etc. Also, the command to verify Docker Compose version is provided here. Now let us install GitLab leveraging Docker Compose. Create a GitLab directory, and in this directory create Docker Compose YAML file. As it is shown in this screen, the directory is created and the Docker Compose YAML file is created inside the directory. Next, we will review the content of Docker Compose YAML file. In the Docker Compose YAML file, we are adding below a script. In this line, we are launching a container using latest GitLab Docker image. In this line, we enable auto restart the container after stopping the machine and restarting. In this line, we are using an environment file that contains environment variable and gets passed to the container at the time of launching. Here we configure GitLab hostname. Here is the list of port used by GitLab, since in our setup GitLab uses SSH to access container in order not to conflict with port 22, which is used by EC2 host. We are using port 30022. Volumes, in here sharing data between containers and EC2 instance, the volume command is used to mount directory to container. The Docker Compose file refers to the environment file that needs to be stored in GitLab directory, and its content stores GitLab home location. As it is shown, it's the path to where the GitLab directory resides. Now you can run Docker Compose by executing up command. In the browser, by going to https www.softwareflowcloud.com, where GitLab is installed, you see that the password for the admin gets set up. The user ID for admin is admin@example.com or root. The password needs to be noted down, otherwise it has to be changed in GitLab_Rails console manually. Here are the GitLab admin user IDs. Note down the password you chose so that in future you can use it. All users can register here. I created a user called Sarah P for myself. In this section, we will install SSL certificate on GitLab container. In order to install SSL certificate on GitLab container, the docker compose.yml file needs to be changed. This requires the docker compose to be down and after changes to be brought back up. Inside docker compose YML, add the line let's encrypt enable equal to true. The Let's Encrypt is a company that issue SSL certificate for free. It's required by GitLab for secure communication between all container, GitLab, Jenkins, etc. Now we need to register GitLab Runner. GitLab Runner is used to run and coordinate the jobs and send the results back to GitLab. GitLab only has source code and pipeline definition. The pipeline gets executed by GitLab Runner. In other words, the GitLab Runner is responsible for execution of pipeline from GitLab repository register. The URL and the token are needed to extract code and pipeline. In this screen, we provide the URL and token to GitLab Runner. Now we need to install container registry on GitLab. The following lines need to be added to Docker Compose file to enable the GitLab registry. We are telling GitLab to host binary. The Docker registry lets push and pull images from the given URL and port. Here's the screenshot showing lines added to the Docker Compose YAML file. After changing Docker Compose YAML file, bring Docker Compose down, then bring it back up for the changes to take effect, and log into GitLab registry on domain software flow cloud :555 to see if registry connected. There is a sample code in GitLab for testing purposes. It's called Hello Happy. We clone it to our private GitLab and commit it to our repository. And since it's a remote server, we finish the job by a git push. We need to do continuous integration pipeline to generate and upload image from source code to the container registry. In order to do that, we create GitLab CI YAML file in the source code. Here is the content of GitLab CI YAML code that we changed and executed at the GitLab runner and resulted to Docker image which got uploaded to GitLab registry. It's located in Hello Happy directory. This is the process to commit changes to the repository Hello Happy and later push it to the remote server. Here is the GitLab page after commit and push. Even though the execution of Hello Happy failed, it shows that the pipeline is working. We had to add a new line in GitLab CI YAML file to overcome the issue we had during running the CI/CD. We changed the content of GitLab CI YAML file, did a commit and push again. Now we have a successful pipeline execution for Hello Happy. Now we install Jenkins. Here Jenkins is installed as a container inside Docker on port 8080. Port 8080 exposes the web interface, and port 50,000 gives you access to a remote Java Jira API. This screen shows that 2 containers are running inside Docker. Also, the initial Jenkins admin password is retrieved by running exec command. The domain password will be used to unlock Jenkins. Now go to Jenkins URL, which is the EC2 public IP address at port 8080. And in this screen, the admin password from the previous screen needs to be entered to unlock Jenkins. Here, the option for suggested plugins have been selected. Here is the Getting Started screen by Jenkins. The credentials for the first admin user needs to be entered here and saved. Make a note of this password for future use. Make a note that Jenkins is configured on HTTP and not HTTPS. Now we are in Jenkins homepage and it shows successful installation of Jenkins. Next step is installing Snyk. In order to install Snyk inside Jenkins container, Docker file must be used. The content of Docker file shows the steps to install npm and then install Snyk via npm. During this installation, user needs to be changed to root and back to Jenkins user. Then a new Docker container gets built. Here is the result of running Docker file and installing Snyk successfully. After a new image of Jenkins is built with Snyk install init, the Jenkins local container gets stopped and removed. Then the new container from newly built image gets launched. Here is the screen output that shows new image Sarah Jenkins running. Next, sign up to a free Snyk account by visiting the URL provided on the screen. A Snyk generates a token that will be used on CLI. Now, log into the Jenkins container and authenticate Snyk with the token that was generated for you on the Snyk site. Next, we need to install GitLab and Snyk plugin in Jenkins. On Jenkins site, click on Manage Jenkins and click on Manage Plugins. Under Available tab, search for GitLab, click on the checkbox. To install Snyk plugin, under Available tab, search for Snyk, click on the checkbox and install without restart. Now that you have done this, you can click on Install Plugins and you will see both GitLab and Snyk security plugins are successfully installed. Now we need to do Jenkins Snyk configuration. In order to do Snyk configuration inside Jenkins, from the Jenkins site, navigate to Manage Jenkins, then click on Global Tool Configuration, go to Snyk section and click on Snyk installation, which is shown in the next screen. In this screen, enter a unique name and ensure Install Automatically is selected. Save the changes. Next, we need to do Jenkins GitLab configuration and authentication. Here are the steps for Jenkins to GitLab configuration and authentication. I will go one by one. Create a new user in GitLab, log in to impersonate that user in GitLab, click the user's icon avatar and choose the setting, click on Access Token, create a token named with arbitrary name. We call it GitLab here with the API scope. Expiration is optional. Here is the token. I only show a portion of it. Copy this token immediately. It cannot be accessed after you leave this page. We will use the token generated in GitLab side and use it in Jenkins. Here are the steps. I will go one by one. Click on Manage Jenkins and then click on Configure System. Scroll down and you see GitLab Configuration section. In the GitLab Configuration section, supply the connection name, GitLab host URL, which is HTTPS, and click on the Add button to add the credentials. After clicking the Add button, the Jenkins credentials provider pop-up shows up. For the kind value, choose GitLab API token and paste your GitLab user's API key into the API token field. Click the Test Connection button. It should succeed. Now we need to clone source code and commit to Git repo. Here are the steps to clone the juice shop, remove its origin, add our own GitLab as its origin, and push the changes. Here is the screen result of executing the commands. Git clone is used in order to obtain a development copy of the juice shop, and all version control operation and collaboration will be managed through the local repository. Git remote removes origin, makes the remote origin no longer be associated with the remote repository, and git remote add origin makes the cloned juice shop project have a new origin, and git push origin master pushes changes from the local master branch to the remote master branch. Next, we need to pull juice shop Docker image and push to container registry. Docker pulls the juice shop image, then we give tag or alias to the image for knowing it by a name, tag name or aliases to the ID of your image, which often look like a magic number. This is a manual process. Pull Docker image, rename it, and push it to GitLab container registry. Now, if we go to GitLab site, we see that the juice shop is pushed to GitLab. Next, we need to install Build Pipeline plugin in Jenkins. Here are the high-level steps to enable Build Pipeline plugin in Jenkins. On Jenkins site, click on Manage Jenkins and click on Manage Plugins. Click on Available tab and search for Build Pipeline plugin. Install Build Pipeline plugin by click on the checkbox. Here is the successful installation of all Build Pipeline plugin. Next, we need to create Jenkins Pipeline. Here are the steps for creating Jenkins Pipeline. We will go through them one by one. First, go to Jenkins and click New Item link on Jenkins dashboard. Enter name for your project and select Freestyle and click OK. On the job configuration page, file the source code management section and select Git. Configure the GitLab connection as follows. Enter the HTTP URL for the GitLab repository field. Select GitLab credentials and select branch. Click Build Trigger links. select the checkbox where it says build when a change is pushed to GitLab webhook, click Apply button, click Save button. To execute the pipeline, click Build Now link on the left menu. To create the pipeline, take these high-level steps. I will go through each one of them. Click on the plus button on the left-hand side of your Jenkins dashboard to create a pipeline. Provide a name for the pipeline view. Select Build a Pipeline View under Options and click OK button. In this page, you will be asked for some more details to configure your Jenkins pipeline. Just accept the default setting and make sure you choose the first job under the setting. Click on Apply and then OK. Here is the build pipeline. Next, we are running pipeline build. Here are high-level steps for running pipeline build. I will go through each one of them. For running a pipeline build, you need to chain your jobs first. For this, go to your first job and click on Configure. Now, under Build Triggers tab, click the checkbox next to Build after other projects are built. Click on My Views. Now, click on the plus button to create a view. Select the Build Pipeline View option and click OK. Under Pipeline View Configuration, locate Pipeline Flow. Under Pipeline Flow, select the initial job to run. Now choose the job which has chains to other jobs as shown in Step 1 and Step 2. Here is the successful build pipeline. Click on top left Jenkins link and click on the Juice Shop pipeline, then click on Configure the pipeline. You will be in General tab. Scroll down to Build Trigger. In the list of triggers, ensure that the Push Events trigger is checked. Optionally, select other events that should trigger a new Jenkins build, such as new tags or new comments. Click on Juice Shop project from Project List in GitLab. From a Juice Shop project, click on Setting, then click on Webhook, then click on Add Webhook to save the new settings. Since we configured SSL, we check the Enable SSL Verification flag. To trust outbound IP in GitLab, navigate to GitLab Admin, Settings, Network, Outbound Request. Select two checkboxes for allowing requests to the local network from webhooks and from system tools. Also, add the local IP addresses and domain names that the hook and services may access. Whenever anything happens to Jenkins, GitLab needs to be notified from Jenkins, and we are configuring it here. We are configuring Jenkins to hold GitLab credentials. Log in to Jenkins admin area and unselect the checkbox where it says Enable Authentication for Project Endpoint in order to disable authentication between GitLab and Jenkins. Navigate to GitLab, Juice Shop Project, Setting, Webhook, Project Hooks, and Test Push Event. Now we need to create a pipeline inside Jenkins for Snyk integration. So we add Jenkins file to GitLab repository to build source code. Here is the content of Jenkins file in Juice Shop. Here are the steps that we need to take to add pipeline tasks to scan source code. From your Jenkins site, right-click on your Juice Shop pipeline and configure it. Add build task under Execute Shell to execute the command required for npm installation. Here we add tasks to trigger Snyk security. We are saying when issues are found, fail the build, and we decide in what's the severity level. In this screen we chose low, so anytime there is a low vulnerability, the build will fail. We can also choose let the build continue. Now save the pipeline and click Build Now button. After the build is complete, click on Most Recent Build, then click on Console Output, scroll down, and Snyk provided a link that once you click on it, take you to list of vulnerability on Snyk site. Here's the list of all vulnerabilities in Juice Shop that's provided on Snyk that is installed inside Jenkins. Here is a simple architecture diagram that needs to be improved. Here is what is covered in this demo. Here is what is covered in this demo. Here is continuation of what is covered in this demo.